Okay, what you need to know, first and foremost, is what is a real, what's a rational, and what are all zeros, all complex zeros. Okay, so what is, if we talk about the set of rational numbers, rational are the ones like 1, -1, a half, a fourth, a third, -2. What are the irrational ones? Pi. But more like square root of 2, negative square root of 2, negative square root of 3, square root of 5, square root of, these are the ones that if you were to convert to a decimal, it would be a non-repeating, non-terminating decimal. It's one of those weird ones that keep going, they fill the calculator screen. Now all of these make up the set of real zeros. These are real, both of these are real. So rational and irrational are real. What if I said square root of 9? What's the square root of 9? It's rational. This is, square root of 9 is rational because it's 3. Okay? So does everyone know the difference? Well, what about the imaginary ones? So when you take the set of imaginary, and what do those look like? Root 2i. What about 9i, 3i, -3i? These are imaginary. These are your complex zeros. So your real, and we talk about imaginary, these are all the zeros. When we say all of them, I want real and imaginary. So real and imaginary are all of them. So how do you do number 3? Number 3, what you're going to do is, I can't factor this. So I'm going to look at plus or minus 1, plus or minus, this is my p-value, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. All over plus or minus 1, and that's it, plus or minus 1. So these are my possible zeros. You're going to try probably 1. When you do 1, 1 does not work. When you put a 1, a -4, a 1, a 12, and a -12. What are these? These are the coefficients from least to greatest. So bring down the 1. You get 1, -3, -3, -2, -2, 10. This does not work because I didn't get a 0 remainder. Now what about if I try 2? If I put a 2 here, if instead of a 1, now I'm going to go to 2. So try 2. I'm going to put a 1, a -4, a 1, a 12, and a -12. Bring down the 1. 2 times 1 is 2. Add, multiply, add, multiply, add, multiply, and you get your first 0. So 2 is one of my real zeros. What's left here is x cubed minus 2x minus, 2x squared minus 3x, and then plus 6. Now you could keep going, but this is factorable by grouping. If you pulled out an x squared, you're left with x minus 2. And if you pull out a -3, whoops, pull out a -3, you're left with x minus 2. So you have x minus 2 times x squared minus 3. So 2 was another 0. Again, it worked twice. And then what do you get with this? X squared minus 3. Set that equal to 0, add 3, and you get plus or minus root 3. So there are 4 zeros, but one of them occurred twice. It has a multiplicity of 2. So 2 and plus or minus root 3 are your zeros. For number 4, you do the same process. This one only wants the real ones. They don't want the imaginary ones. When you do synthetic division, 3 works. put a 1, a -1, a -3, and a -9 out. Bring down the 1. 3 times 1 is 3. You're going to add, multiply, and you get your first 0. So 3 is a real 0, but what you get here, 1x squared plus 2x plus 3, if you try to factor this, you're going to say it's not factorable. So I use completing the square. I set this equal to 0. I subtracted 3. Now I took half of this and squared it. And right away I'm seeing what? What are you seeing right here? A square root under a radical. That's going to give you an imaginary number. Is an imaginary number a real solution? No, it's not. If it said find all solutions, if it said find all, you would say 3, and you would say -1 plus or minus root 2i. This would be all, if it said all, but it only asks for real, so the answer is just 3 for this one. The answer for that one is 3, but if it says all, you would put both of them. In the last one, number 5, they want all of them, real and imaginary. So when you do this one, -1 works. You get 2, 1, 0, and 1. Bring down the 2. -2, add, multiply, and you get -1. That's your first real 0. What you have to do with this part right here is I would use the quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. You get 1, hang on, plus or minus, you get plus or minus 7i over 4. So does everyone have this? When you do the quadratic formula, that's what you get. Thank you.